Our topic, manufacture of hydrogen and oxygen by electrolysis of water. The manufacture or manufacture of hydrogen and oxygen by electrolysis of water. We want to discuss what is examined by our syllabus ZIMSEC 4003. All together. So, normally let me put a typical question on this topic, which came in 2001, paper 2, November. It was question number 7. So the question is, describe the manufacture of hydrogen and oxygen by electrolysis of water. This is a typical question which you have to answer. That time it had 7 marks that time. Yakangana 7 marks exam kangwa iyoyo. Right. So let me draw the diagram. I'm going to answer the question now. I will do it later after the discussion altogether. Then, so the diagram is like this. This is the cell. This is a battery. This is my battery. This one is a bigger bar is the positive. The smaller bar is the negative. The bigger bar is positive. The smaller what is negative. Altogether. And actually one is on cell. I want a battery. So this battery has 2 cells. So I can put a variable resistor here. A variable resistor for my choice sake. Then you can put ammeter if you want, for the sake of understanding. Then so let me just do it now. So this is this is water. So this is the diagram. So let's label it now. We said this is the battery. This is our battery. What is this one? I said what? Variable what? Variable resistor. Variable resistor. Then this is our ammeter. This is inverted test tube. Then this is external circuit. External circuit wire. Then this is the anode, the cathode. Yes, anode, sorry, anode, correct. This is the cathode. I will tell you how do we identify the cathode and the anode. And this is acidified water. Acidified water, some call it dilute sulfuric acid. Dilute sulfuric acid. This is electrolyte. Right. So that is our setup for the manufacture of oxygen and hydrogen by electrolysis. So if they say describe, you might draw the diagram so that at least you don't struggle in answering the question. Is it fine? But if you are not able to do the diagram, just describe. So, the guys are about diagram. Ini battery in Shona. Ndoba powerhouse. itambo kai emagetsi kai. These are mvura yanditi inozi acidified water. Kuna kuti mvura nechi ine acid anditi because it acidified. Kana kuti some call it dilute sulfuric acid. That's our electrolyte. Anditi a liquid that connects the two electrodes. Anditi. Then there's a tube here on each what electrode. Right, so guys, I put the terminal battery and put the battery. Tina sungira kui inonji. Kazo nani? Are you sure? Are you sure? Put the battery. Tina sungira kui. Put the battery. Tina sungira kui. Eh? Put the battery. Tina sungira kui. With the rule, the panel rule, the panel G rule. Panel. Put the battery on it. In the anode. In the be Sagachi. I don't put the very sending a G. How done it? Thank you very much. We made a mistake here. This is how they did the rule. Put PM G. Put the battery on it. Any G anode. However. Therefore, often the Chayashi cathode. Right, here between these two, one tube is what oxygen, energy, hydrogen. How do I identify oxygen hydrogen here in these two test tubes? So when I say oxygen, hydrogen. With the panel, the word G panel. Push stands for what? Positive. Of the battery. N, wait, G anode. Co-O oxygen. And this, so this way we have oxygen here. How together? Then cathode is spelling in H. What H wangu? Ndio kuna H hydrogen ulo. Nenziwa bela. Mani baba. Kurakuti the anode ne cathode tinozo that environment ni chitsotsi chokuti chi we have the panel is an abbreviation for G for positive terminal connects to the anode and collects what oxygen. From the way the cathode is spelling it has an H, which means that's why we get G hydrogen. Then wherever we have hydrogen and oxygen they form water. So for every 2 moles of what? 2 volumes of oxygen, hydrogen, we have 1 volume of what? Of oxygen. Correct. Hydrogen from the H2O on it is double in amount compared to what? To oxygen. Hydrogen like 1 like a oxygen. Sa you know what up? Yakwana ndiga nditi. Sa nigga kupi? Yakwana ish. It's specific ish. What specific? This was space ish. This space here, here do you go? Nigga show man somewhere here. See this. Look this small space ish. Don't you oxygen? This is how you figure out the oxygen and hydrogen. That's go way up. That's go about it. You should be able to identify the anode. Be able to identify the cathode. And then what you should be able to identify where oxygen is collected and where hydrogen is also collected. Let's go. But from the way the panel, it can tell you everything. All together. Then you should also know the volumes of the gas collected. Hydrogen is double oxygen. It's double G oxygen from the ratio from the ratios in H2O. All together. Then this acidified water is an electrolyte. Don't supply my ions edu at breaker because electrolysis is the breaking down of a substance by passing electricity through it. Marangara, the breaking down of a substance by passing electricity through it. So If we pass electricity here, the ions, there are some ions which are inside this, which is hydrogen ions, hydroxide ions, sulfate ions. So some of these ions must be broken down to form oxygen, what? The hydrogen. That's what about it. Second, that's all about the diagram. So let us write down, let's identify first point, ions present. Ions present. Don't go very far. Can you see that? It must be large. Ions present. Energy about hydrogen ions. You know H plus. That's its chemical formula. H plus. We also have hydroxide ions. Some of them hydroxide, others say hydroxyl ions. The symbol is OH minus. Then we also have sulfate ions. Sulfate ions, the symbol is SO4 2 minus. So you should also know the ions present. Let's go. Then you should also know the electrolyte used. Altogether, you can say acidified water, but no marker. Or you can say dilute sulfuric acid. Vandivuti, but no marker. That's go. Then we should also know the electrodes used. Electrodes used. I'm telling you what is examined, guys. The electrodes used. So, both electrodes are made of platinum or carbon. Carbon is also called graphite. So these are we're going to compare these two. So, platinum is preferred to carbon. Why? I can say advantage of platinum over carbon or graphite. Platinum is a better conductor of electricity altogether. So advantage of advantage of platinum over carbon, so-called graphite, is that it is a better conductor of electricity. Let's go. Altogether, one of the advantage of graphite over platinum. Graphite is compared to platinum. It is innate. So it is innate. It does not react. Let's go. I react. It is innate. Let's go. Then one of the people the anode is connected to the G. The anode, let's say the electrodes are made up of what? The electrodes, I'll say one anode here. Triple anode. What do we say about anode? It's a positive G electrode. What is it? It is the positive V. Very good. It is the positive electrode. The positive V electrode. What else? It attracts negative ions or anions. And it attracts negative what ions? It attracts negative ions and anions. Ndo zakare pa anode ndo bandika inonzi oxidation. And so it's the state of G oxidation. Zero D, loss of electrons. All together. Loss of what? So it's the site of oxidation. It is the site of oxidation. The anode. Anode ndiye positive, right? Ndo ndiye anopesha ma negative ions and ma anions. All together. E.g., here, hydroxide ions and sulfate ions. SO4, 2 negative. Right? Ions we are going to command nani na anode. So anode you bandika chi oxidation, chi loss of electrons. How do you know? Oil. Oxidation is the loss of electrons. Oxidation is the loss of electrons. Rig. Reduction is the gain of electrons. So not oil rig. Rig. Oxidation is the loss of what? For electrons. Reduction is the gain of what? Electrons. That's go. Right? And then item 2. Adebaji per cathode. Cathode do amena same chida we. Do negative G electrode. It is the negative electrode. Yes. Then Zakare, what did you say about do particle G reduction? It is the site of what? Reduction. Could be gain of what? Of electrons from the way they read. Zakare attracts my positive ions, and which are called cation ions. It attracts positive ions. That's my cation ions. Let's go. Right. So that's all about these two electrodes, the anode and the cathode. The full information. So give us examples of these ones, like e.g., for example, hydrogen ions. They are being attracted by the cathode. Together, are we guys? Are we together? Right? So we talked about the anode, the electrode, also the electron. What about the battery? The battery or simply cells provide electrical energy. All together. Providing electrical energy. Provide what? Electrical energy. Do battery repart. Then, other parents will come cut. What happens on the electrodes? And the electrode reactions. Electrode reactions. So let's start with what? With anode reaction. what happens on the anode? My negative ions anofamba huenda pa anode. Mawera ma negative ions anofamba huenda pa anode. Mafambire ions migration. Ions migration. The negative ions migrate to the anode. Negative ions migrate to the anode. As kappa anode, they are going to lose electrons in the oxidation. And then they form what? Gases or other atoms. Let it more specifically here. Sakapana bandit. Tine two ions which are negative here. Tinema hydroxide ions, nema sulfate ions. Sakabari vaviri. And Ulianu, the sulfate ion, initially hydroxide ions. This is the anode. This is the hydroxide ion. Ulianu, the sulfate ions. We are both negative ions. You know, in the anode. We are one trick. As who you know the sulfate that is Vashoma and it Mukabayo and it then my hydroxide ions. So I don't famba what is famba as a trick and it. Remember as a Kunozigachi hydroxide ion and it. So Saka Kufamba bani hydroxide from the electrolyte on the anode discharge. So hydroxide ions are discharged on the anode. We are not sad. That's Baba Mama. Ashika Papo, the sugar. Do not damuka into three pieces. Into three G. It may not the electron issue. And it may G oxygen issue. It may have Vura. Because that's G Vura. Don't look at them. What do you have? What do you have? Depends on. Alright. Tabangani kuzia. Tibangani. Trimui mu electrolyte. And it. Saka nunda kupi ku anode. We are being by the anode. Those alliances attract. We have a positive value in the negative value. We are both negative. So to know what because of G, attachment between G, negative and positive value. So we are both trying to draw the G, and they, so almost and they, we are just kilomita in Dino Furaga. I am discharged. That's the papa one. In it, I just said ions. Don't break into three parts. You don't see electron. What is it? You know, Tambuya magazine. This is what Tindera did. Dina anode. I did. Oxygen. If I tell me Mukabani, Ribat, Gabari goes what you. And it. Mutes Ribani. Vura never to Rabai, Mugaba. And it. Mawena. This is a party anode. Let's go. Right. The guy in your attitude. The Abasana. So the Japanese hydroxide ions, and sulfate ions are attracted by the anode. How do you do that? What hydroxide ions are discharged because they are in greater concentration. According to in greater concentration here. And is it? Then what is it? Hydroxide ions are oxidized by loss of electrons. To form oxygen and water. You actually have a question. The OH, let me just give a space here for balancing. I do that. When I do that, I do that again. You know, they say it is G oxidized. Altogether, it will lose electrons. It will form oxygen. It will also form what? H2O, Vura. Then, plus electrons here. Is it fine? To balance it off, I can put a 2 here. And 2 plus 2, I need, they have 4 questions again. I can put a 4 here. So I'm going to put a 4 here, 4 electrons here. So that this is what happened on the anode. Then we tell them what happened to the electrons, to the hydrogen, to the oxygen, and water. What electrons? Electrons flow to the cathode through the external circuit. External what? Circuit. Circuit. What comma? Oxygen is collected in the inverted test tube. What comma? What end? And water enters back into the electrolyte. All together. This is the anti-reaction. That's power. Then this way, please, can also bring as you can solve 4OH. What is it? Minus 4 electrons here. What is equal to O2 plus 2H2O. So have 100. It is the same. Don't repeat. I'm trying to say that's the way of writing this equation. Multiple choice. How together? Now I'm going to loss of equation. This is negative. And no loss of electrons from G. This one is more informative. And here is what I'm going to say. And then by G, cathode G reaction. Cathode this H, please. Cathode reaction. Let's try to hammer on it now. Only hydrogen ions are added to the G, the cathode. And hydrogen ions are attracted to the anode, to the cathode. Could you imagine this? What are guys? Yeah, when this is our cathode. This is cathode. You agree? You cathode guy. Is it G? Hydrogen G ion. Hydrogen G. As we do electron, in G hydrogen. We do electron. You look at right. Second, we another party and this one is sorry. We need a material. That's the one. Pakubi, another need. You look at. That's what Pakubi. So I really put my cathode here, please. You can't have a better. We never do. We need cathode. You need that hydrogen ion. Then there could be cathode. We must want to show now I don't say that. All of our farm at the time we had it. When there could be cathode. When I farm, I don't know what it is. Well, only number you tell video. No, I don't do. No, I don't do. Electron. No, I delete. Electron. Ashuka bachi cathode. Madrage technology circuit. India to iron. Do famba nanzi migrate kandi. Jenda kupi cathode. I join with what? Join up. Then we combine to form hydrogen gas. So in hydrogen ion, I get G electrons. We form hydrogen gas, not reduction. Hydrogen ion. Jikanda pachi cathode. Don't know about it. We are get on the hydrogen G ion. I got to be anode. Patsimka, I did a break into oxygen water. Oxygen, I kept to it. Then we have a energy. It's not second by Akubi. Then a Basanani. Now, hydrogen. However, I will. You have the energy gas. So, by the way, the government will test tube. That's why we have. It will be hydrogen. Kurabi, hydrogen. It will be cathode. Oxygen will be anode. Some mubikiro use electrons of water. This is what I'm saying. Yanzibawe. Tadiwa. Safam. Are you sure? Anyway, it's ions are discharged and get electrons. Electrons by reduction to form hydrogen gas. I did it. Question. And then plus 4 electrons and by 4 to give us H2. Do it together. What about hydrogen gas? Hydrogen gas is collected in the inverted what? Test tube. Saga, this one, this are the guy, though, what the person is be. So the idea is this guy, the manufacturer of hydrogen by little water. The others here, from here, go out of electricity reactions. Let's go it up. And I'm to you through these electrical reactions. Right? One of the Java measurement, use of what? Use of oxygen. 2 and 3. The most common one, where the use of oxygen in hospitals to resuscitate life. Oxygen. This is what else? Welding. Then this is also oxidizing agent. In many industrial processes, oxidizing agent. These are the best 3 others. Then use of what? Of hydrogen. Use of hydrogen, like 2 or 3. Hydrogen, if you want it, it's also a fuel. It's a fuel. What is that? Oh, it's a fuel. it can bend to release heat. Hydrogen, it was a margarine, and it was a marine. Yes, making margarine. So hydrogen, it can also be reducing G agent, reducing agent. Lastly, manufacture of G ammonia by the Haber process. This will have manufacture of G ammonia by the Haber process. Is that a use of what? Of hydrogen. Think up the solvent, please. You might have yours, not a problem. Then they can ask you ratio of hydrogen to oxygen. It is G 2:1. Don't forget, please, that. Then you have oxygen. They're going to vice versa here. Hydrogen is equal to G 1 to G to 2. This guy is basically the best or the most important aspects on electrolysis of water. I think I've said a lot on this topic, and I have to raise my case here, guys. I've said as much as possible on this aspect of electrolysis of water. I expect you to replay this video each and every time again. Every time, go to our YouTube channel. If you have not subscribed, like our new girl, go to the Learning Center channel, subscribe. You click on the notification bell, then you can see all our videos. In the new uploads, you are notified as well. Then it is zero cost to subscribe. No money required. Only the screen is going to be used. Then download all those videos. Play them at home. Repeat. As you repeat, you learn by what is called classical conditioning. Linux. As you repeat something, you understand it naturally, like just like a song. So these videos, I want to make them songs. Play them every time. You end up knowing things unawarely. That's the one thing I'm saying. As you repeat these videos, play them once again and again. You are going to learn naturally. Classical conditioning. It's a very good way of learning, where you struggle with understanding how to get it. Right. So, in our next lesson, we are going to look at the electroplating or coating processes. So, thank you very much, guys. Let's meet again in our next lesson. Good day.